Yes, so hello, good morning. So I'll be presenting you my ML project. So our ML project. So now we'll be like saying as we are entering the world of neural networks and the application. So we are planning to help like human written text in a very AI oriented way. So this technology is powered by advances in machine learning, and particularly deep learning is not just an academic curiosity but also a practical tool with application in various fields such as entertainment, business, and education. So introducing to a data set and problem definition. So like our task is to generate a text using a character-based model, which we will use a data set consisting of song lyrics, which provides a rich linguistic structure ranging from simple to complex sentence forms, packed with emotions and storytelling elements. The dataset contains over 4 lakh characters, providing the ample material for training a model. So first we see the pre-processing thing. We import the necessary directories and libraries. So the initial step in our workflow involves pre-processing the data to make it suitable for training a neural network. This begins with reading the raw text from a file, understanding the basic structure, and finding, like, for example, the length of the characters. So then uh, we sort out the characters and find that there are 98 unique characters uh, present in the file. So next we map these characters to the integers because neural networks do not understand text. So this is mapping is done to two dictionaries, the char to idx and idx to char. Yeah, here we can see it. So this will help in the encoding and decoding of a text. Then we find creating training examples and targets. So our next task is like to converted a text is converted to integers. The next task is to form training examples from the networks we can learn. So here we create the examples for reports. So for each sequence, we also prepare a target sequence, which is the original sequence shifted by one character to the right. This teaches the model to predict the next character in a sequence after seeing the first few characters. So next is like, yeah, here we split and we provide input and output data. Then finally we come to building the RNN or the neural network. So we use a type of recurrent neural network, the RNN, that uses GRUs, that is the gated recurrent units. So RNN are well suited for sequence data like text or time series because they have more memory elements that capture information about what has been processed so far. In our case, the character is seen up to a certain point, so it has an embedding layer. Then yeah, there's an embedding layer, the first layer, and embedding layer, which turns integer encoded characters into fixed size vectors. Then we see the GRU layer. Here we have provided it. The core of a model is like GRU based. So GRUs help the network to remember and forget information through gates that regulate the flow of information. This is crucial for understanding context in text. Next, we provide a dense layer. After processing the information through the GRE, the output is passed to a dense, like a fully corrected layer. So this layer has many units as there are unique characters in a dataset. It outputs a probability distribution over all characters, indicating the likelihood of each character being the next one in the sequence. Then we see the dropout layer, which that reduces overfitting, which can be a common problem in TL models. This layer randomly sets a fraction of the input unit to zero at each update during the training, which helps the model to generalize better. So next we go for training a model. With a model architecture defined, the next phase is training, of course. So we compile the model with an optimizer and loss function. So the training involves passing the prepared batches of input sequence and the corresponding target to sequences. Uh, yeah, yes, provided. So during training, we use callbacks to say the model weights at various stages. This allows us to reload and use the trained model at any time in the future without retraining from the scratch. So we create checkpoints and the number of reports and all. So then we keep a generate text function. to generate text with the trained model. Like post training, the model is capable of generating text. So we start generation process by providing a seed string which the model uses to start generating characters. The model predicts the next character based on the previous character. The temperature parameter is being given here, which allows us to tweak the randomness of predictions affecting the creativity and diversity of the resulting text. So we can see here the text has been generated. So like text generation models have wide array of application in the entertainment industry. Like they can be even used for creative writing pieces, scripts, or even music. In business, they can automate customer service interactions, generate product descriptions. In education, they can provide tutoring assistance, or even generate educational content. So yeah, so in conclusion to today's today's like session of a presentation, so we have seen how the neural networks can be utilized to understand and generate human-like text, capturing the intricacies and styles of language. This technology not only enhances our understanding, but it's also a crucial part. Like as we continue to refine the models, we can expect to become an integral part of various industries, augmenting human capabilities and transforming how we interact with machines. Yeah. So this is our project. Thank you.